Welcome to the fourth session of the third module. In this module, or in this particular session, actually, in the previous module, we have discussed the working principle of two-stroke petrol engine and uh, two-stroke petrol engine and the four-stroke petrol engine. Meanwhile, we have also discussed the four-stroke diesel engine also. As the two-stroke diesel engines are getting obsolete, they have not been used extensively in the other fields because of its own deficiencies or the drawbacks with a very low efficiencies. So basically what happens, every engine, though you have got 10 cars, all the 10 cars are working with the same basic principle of Otto cycle. If they are all the 10 cars are working with the same fuel as a petrol, but still they generate different powers. They have got their own identity with the power, or it may be a mileage. You might have heard about one vehicle gives 100 mileage, whereas the other bike, it gives only 60 mileage. Why this mileages? Or it may be a power, or it may be load carrying capability, or it may be the performance also. It just keeps varying. Every vehicle has got its own identity of its own producing the performances. How this performances varies. So rather we study about this performance study, we need to study the basic parameters, what actually it means for the parametrical studies, basic design, or it may be a performance parameters in internal combustion engines, which includes a lot of factors. Maybe it may be a compression ratio, that is what we call it as an RC, and we call it as a swept volume, we call it as a clearance volume, and then the power output. In the power output, once again, we have an indicated power, and then the brake power, and then the frictional power. So in the power itself, we have got indicated power, brake power, and the frictional power. And then we also have a thermal efficiency, indicated mean effective pressure, brake mean effective pressure, specific fuel consumption, and more. Many factors plays a very major role. So that is what, even if you go to a showroom and ask to buy a bike, or it may be a car, they will give you a catalog where the specifications, starting from its design size, or the capacity of seating, or so many technical aspects also they will give it. Say for example, one small example I would like to tell you: the torque that it generates. Higher the torque and more the power it generates. It tells what is the cc of the vehicle. What do you mean by cc? Cc means cubic centimeter. That means so much of volume of the fuel it does takes. Is it clear? No, that is what, even if you take an engine performance parameters like a power, torque, or a specific fuel consumption, more the fuel consumption, less the mileage. Less the fuel consumption, the more mileage. So this is what one dependent on the other factors also. So that is the reason why we will study all these basic engine performance parameters. The brake torque is normally measured with a dynamometer engine. It is mounted on a test bed, and the shaft is connected to the dynamometer. So the different ways are there, but let us not worry about how they measure it, how they work it out. But it is our interest that we have to find out what are the different performance parameters. Even if you ask me how can we increase the power output in an IC engines, we can increase it by the displacement downsize. Is an exciting technology in one of the IC engines in the recent days, in order to reduce the toxic emissions and fuel consumption simultaneously. Is it clear? So such kind of various factors also affects on the performance studies. So out of which, let us consider one of the important one, which is necessary. Now these things can also asked in the theory questions, and these are also plays a vital role in solving the numericals. Okay, now if you consider this, what do you mean by an indicated power? The total power, the final power that is being developed by the combustion of fuel in the combustion chamber is called as an indicated power. It can be calculated as indicated power is equal to N into PMI, P suffix MI, L A N into K divided by 60,000 watts, or it may be into 10 divided by 6 kilowatts. where N is nothing but the number of cylinders, and PMI is nothing but indicated mean effective pressure. It is nothing but I stands for indicated, M stands for mean effective, and the P stands for the pressure. Is it clear? So that will be in terms of bars. So L is nothing but the length of the stroke, A is nothing but the area of the piston, which gives us pi d square by 4. The cross sectional area, I am talking about the area of the piston. Area of the piston is almost equal to the inside diameter of the cylinder. Then K is some constant, which is for 4-stroke engine, it is a half for 4-stroke engine. K is equal to, actually I have not mentioned it, I am so sorry. K is equal to 0.5, or it is half, 1 by 2. K is equal to, value is equal to 1 by 2, constant value. You can take it directly for a 4-stroke engine, and for 2-stroke engines you have to take K is equal to 1 for 2-stroke engines. Is it clear? So it is a constant. Now I just shall go in detail now. If N is equal to number of cylinders, how does it affect an indicated power? Now there will be a flywheel which will be a common for a number of cylinders. Now I have a 4 cylinders I have. Is that clear? Now I have a 4 cylinders, 1, 2, 3, 4. All the 4 cylinders output, or the output shaft or the crankshaft, will be coupled to a common flywheel. Whenever, whether this engine runs or this engine works or this engine works or this cylinders, all the 4 cylinders, whatever the output is coming, the total output will be taken out to this. If there is 2 cylinders, the power generated will be less, obviously. If there are 4 cylinders, the power generated will be more. If there are 10 cylinders, say for example, if you go for a multi-wheel, multi-axle vehicles, you will have more than 6, 7, 8, 10 cylinders will be there, 12 cylinders will be there. So in such kind of cases, what happens, the power that will be achieved will be more. That is the reason why number of cylinders will directly proportional to the indicated power, because it is multiplies. Say for example, if you have 2, the indicated power is 10 watts for 1 cylinder. For 2 into 10, it gives around 20. Is it clear? Now exactly point. And then now I'll come to the mean effective pressure. I just shall go in detail about this mean effective pressure in general, in a brief way. I can say, if this is a cylinder head, if you take my hand is a cylinder, a piston, this is a cylinder in which the piston is moving up and downwards. The piston moves up and the piston moves downwards. Piston moving up and piston is moving downwards. Now what happens when the combustion takes place over here? The gases, the burnt gases or the product of combustion will exert a force onto this. So this piston will move up and downwards like this. The mean, because it is an uneven surface, so the pressure that is being exerted by this gases is called as a mean effective pressure. Is it clear? So I'll go in detail later on stages. Then the length of the stroke, the piston TDC to the BDC, 1 stroke, from BDC to the TDC, 2 strokes, from TDC to the BDC, 3 strokes. So it is going, but what is the stroke length? From TDC to BDC is equal to the length from BDC to the TDC. The length moved, the distance moved from TDC to the BDC is equal to the distance moved from BDC to the TDC. So the length doesn't alter. So that is what we call it as the stroke length, that will be given in terms of meters. It will not be in meters, but we will convert that into meters. Is it clear? Okay, that will not be in meters. Meters becomes it. The engine becomes itself will becomes a big carryable things actually. It becomes a load. Then the area of the piston. Area of the piston is given by the pi d square by 4, whereas d is nothing but the diameter of the piston. And K is a constant which is taken as a 1 by 2 or 0.5 for 4-stroke engine, and K is equal to 1 for the 2-stroke engine. Okay, now I will define what we mean by indicated power. Now basically what happens, whenever the power is being generated, the actual power the actual power which is being generated inside the engine cylinder. Inside the engine cylinder, that is nothing but an indicator power. Do we get the same amount of power output for our wheels? No, it is impossible. I will tell you, lot of factors will greatly influence on this. A lot of factors will influence. Whatever the ideal, we also call this as an ideal power, or we also call it as an indicated power. The actual power that is being developed in the engine cylinder is called as an indicated power. Is that clear? Now, indicated power is the total power of the engine, which is graphically represented by the area of a cycle on PV chart, as the actual PV diagram of an engine is drawn by the indicator mechanism. Okay, this power is called as an indicated power. Is it clear? So this is very important. Among all power which is being developed in the engine cylinder, indicated power will be the maximum. That is the reason why we call it as an ideal power. Is it clear? Now let us go to the brake power. In the brake power, what happens? The power available at an engine output shaft is called as its brake power. The power which is generated in the engine cylinder is nothing but indicated power. The power available at an engine output shaft, by the time it comes at the output shaft, it will be reduced because of the friction, because of the load, because of the mechanical inaccuracies, because of the heat which is being generated, because of the transmission losses. So there are n number of factors which makes the brake power, the indicated power, to be reduced when it comes to the output shaft. So that is what we call it as a brake power. It is the power which can be positively used against a resistive force or braking force of the applications for which engine is being used. It can be calculated in two ways. One expression is BP, that is the brake power, is equal to 2 pi Nt divided by 60,000 kilowatts. This is one expression, where N is nothing but the engine speed. The engine speed, it is an engine speed. The speed of an engine in terms of revolutions per minute. That means how much the engine is rotating for every 1 minute. What is the number of revolutions it is making? And then T is nothing but torque. Torque, you are already familiar with that. The force with respect to the meter along the distance of length, it is nothing but the torque. So T is nothing but the torque at the output shaft, which is given in Newton meter. dP is equal to, one more equation, same thing, if you can remember, this is Npmi LANK 10 by 6. Same here, Npmb LANK into 10 by 6. Now here what is happening is the same thing except the mean effective pressure. Now here PMB is nothing but brake mean effective pressure. There we had indicated mean effective pressure. Here we are having the brake mean effective pressure. The torque of an engine depends on its size. Is it clear? That is area into length. Okay, and mean effective pressure. The torque also engine depends upon the size, the area, and the length, spoke length, and as well as the area of the piston. And the mean effective pressure, there are two factors. The torque of given engine, of constant size will be more when its mean effective pressure is more. Hence, mean effective pressure is a true parameter to compare power of the engine. This is what is an important factor which plays a major role. So, compared to this indicated power, our common sense itself says the power which is generated inside the engine and the same power which is available at the engine shaft end, output shaft, is different. So the output shaft, the common sense itself says this power is less compared to the ideal indicated power. Okay, then these are the two important performance parameters. Next one is a one frictional power. So indicated power is so much, it has been so much, and then the power which is available at the engine shaft end is different. In the engine is different and the shaft end is different. Where is the loss of this power? The difference in this power is nothing but a frictional power. Okay, it is the power required to overcome the initial internal friction of the engine. It represents the total losses occurred from indicated power. It is the difference between indicated power to the brake power. Is it clear? So that is the one. Mechanical efficiency actually I discussed to overcome. The next one is a mechanical efficiency. It is nothing but the ratio of brake power to the indicated power. The ratio between brake power to the indicated power is being given as the mechanical efficiency. Is it clear? That is nothing but mechanical efficiency. Now let us talk about indicated mean effective pressure. Indicated mean effective pressure is also defined as the hypothetical pressure. This is defined as the hypothetical pressure which is thought to be acting on the piston throughout the power stroke and does the work equal to the mechanical work generated per cycle of the engine. It is also called as indicated mean effective pressure as it is usually determined with the help of PV diagram taken with the help of an indicator mechanism. The area of PV diagram drawn by the indicator mechanism can be calculated by any measurement method. Then the indicated mean effective pressure can be determined by PMI is equal to net area of diagram in mm square divided by length of the diagram in mm and Sprint's constant in bar per mm. So that will give rise to the mean effective pressure. Basically what happens, the mean effective pressure can also be defined as it is an actual power which has been generated in the engine cylinder which cannot be calculated with some instruments actually. This is a quantity related to the operation of the an engine and is a valuable measure of any engine's capacity to do work. That is independent of the engine displacement. If that is the case, a mean effective pressure if you take it in particularly with the Otto cycle, generally the mean effective pressure it is also defined as the ratio of net work done to the displacement volume of the piston. Displacement volume of the piston with the net work done. Since this mean effective pressure cannot be, it is a highly dynamic conditions where it is happening inside the engine cylinder where the temperature is around 1000 degrees centigrade. So it is impossible that we can weave it or we can have some instruments or sensors which can measure that. So what happens it is only we will use it with the ratio of a net work done. If some work is been done with the engine, then what is the net work done with respect to the volume of the piston that is being displaced. Is that clear? Now what is the beginning of the compression stroke? If the temperature is around 300 degree Kelvin and pressure is 100 kilopascals, the thermal energy Q is supplied maybe around certain, then the indicated power or the mean effective pressure can be calculated using certain data like this. Is it clear? So the average pressure produced, it can also be considered it because the surface area. Now if you take this as a surface, if you take this as a surface of the piston, now the area will not be a flat one, it will be always like this. So the pressure which is exerting at this point is different than the pressure which is exerting at this point is different. Theoretically, whatever we are talking, it is only a theoretical calculations. So what happens at all the points it will be different. So what I will take it is, or what I would like to define it is also, it is defined as, maybe we can take it as an average pressure. It's an average pressure produced in the combustion chamber during the operating cycle. That is what in simple words we can put it. It's an average pressure that is being taken or that is being produced in the combustion chamber during the operating cycles, or it may be during the strokes, during the 4 strokes of an engine if it is a 4-stroke. It is an expression can also be given of the theoretical friction power, which is known as an indicated horsepower also. Is it clear? Now the units that we use it is nothing but a pascals, or it may be in a bar, or it may be in a kilopascals, or it may be in kg per meter per second square, or it may be in the kilopascals also. See, that is the use of this mean effective pressure. And this mean effective pressure, if it is we take it as for the IP, that is to calculate the indicated power. If you want to consider it, it will be indicated mean effective pressure that can be regarded as an average pressure in the cylinder itself for complete engine cycle, for one engine cycle from suction, compression, expansion, expansion and exhaust stroke. So if it is a 4-stroke engines or anything, one complete cycle, whatever the pressure that is being generated, that is what we take it as a complete engine cycle. The average will be taken. That is what we call it as an indicated mean effective. The brake mean effective pressure is nothing but the other thing, whatever the pressure that is being averaged until the power that will be reached to the shaft end of an engine. That is what we call it as the mean effective and brake mean effective pressure. And even in case certain things where this mean effective pressure is been calculated backwards from the measured brake power using a that is with the diagrams also we can find it out, where the using a pressure, using the length of the stroke, the pressure that is being generated and the length of the stroke and the area of the piston or inside area of a cylinder, and then n will be the number of power strokes that it has been indicated. The same one, if the indicated power and the pressure will always be greater than the mean effective pressure and the brake power because of the frictions that is being generated in the engine. Then what do you mean by this brake mean effective pressure? Brake mean effective pressure can be given as the torque into the displacement, torque to the ratio of displacement. It is also can be explained with an equation called power pulse per revolutions. There is one thing which is not in your syllabus, so let us not worry much into this. So this is a very important factor in deciding the indicated power. Similarly, if you consider the brake mean efficiency, brake mean effective pressure, it is also a hypothetical. It's also a hypothetical. That means we cannot exactly find what is happening there. Hypothetical mean effective pressure acting on the piston and which is based on the brake power, just like IME. Indicated mean effective pressure in the same way, we will also calculate the similar one for the brake mean effective pressure on indicator. If there is no friction or other losses than the BMEP, then it will be obviously indicated mean effective pressure is equal to brake mean effective pressure. So for the calculation purpose, most of the time we just assume that there is no frictional losses in certain occasions, but in practical what happens, there will be 100% the frictional losses is meant to occur. Okay, as the power depends on the size and speed, therefore it is not possible to compare engines on the basis of either a power or a torque. Is it clear? However, the mean effective pressure is a true indication of relative performance of the different engines. Now let us talk about the specific output. Specific output is being defined as the brake power output, that is Vp of the piston displacement, and it is a parameter which relates the power of an engine with its size. So it is an important performance parameter. Now you might have seen many vehicles where there will be a 7-seaters will be there, and then there will be only 4-seaters will be there, but the capacity will be maybe the same. Engine capacity for a 4-wheeler may be same, and the same for the 7-seaters, engine capacity may be the same. In that cases, say for example, I have got two vehicles. Both the vehicles, this is 7-seaters and this is 4-seaters. Both engine capacity is same. Then what happens the output? Engine capacity may be the same, but the output always depends upon the size of the system. That is what even I have mentioned before. As the power depend upon the last para, as the power depend upon the size and the speed, the power actually depends upon the speed as well as size of the system. So it is given by, so BP divided by A into L. A is nothing but area and L is nothing but the length. And this can be also equals to constant into PMD, the brake mean power into revolutions per minute. N will give you a specific output. Is it clear? That is the beauty behind of it. And then we have also have the volumetric efficiency. A mechanical efficiency is nothing but BP by indicated power by brake power. I'm so sorry. So brake power divided by an indicated power. Whereas the volumetric efficiency is always given by actual volume of charge supplied at normal temperature and pressure divided by swept volume. It's the actual volume charge that is being sucked. It is being sucked. The suction during the suction stroke, what is an actual volume of charge which is being sucked divided by the swept volume will give rise to a volumetric efficiency. I once again define. It is defined as the ratio of actual volume as reduced to normal temperature and pressure of the charge or air drawn in during the suction stroke to the swept volume of the piston. Normal temperature and pressure volumetric efficiency is an important performance parameter which directly affects the power output of the engine. More is the volumetric efficiency, more is the charge sucked per stroke and more power is being produced. That is nothing but whatever the, if you take an engine injection cylinders, why I always give you is because we can visualize what is happening. Now, when you suck it, when you pull the syringe knob downwards, what happens? It will swept a certain volume of the medicine or an engine charge. So it is nothing but swept volume. Actual volume of the charge that is being sucked will be different. Will it suck the same amount of the swept volume and capacity? No, it will be less. Higher the volume that is being swept, the higher the efficiency. More fuel if you are getting for the combustion, then you will get more energy. Less energy, less fuel you are getting, so obviously the less energy will be produced. So that is why volumetric efficiency directly influence on the power output. In the fuel, air fuel ratio. Now in the air fuel ratio, it is the ratio of mass of the fuel to the mass of the air in the fuel air mixture. Sometimes it may be given as air fuel ratio, AF. Capital A and capital F is being used. The mass of the air and to the mass of the fuel will always play a vital role. My dear friends, I was just talking about in the petrol engine. In the petrol engine, the air and the fuel will enter into the engine cylinders. Correct? Now, that is what we call it as the air fuel ratio. That it will be mixed in a carburetor. Carburetor is a place where the petrol and the air will be mixed. How much of the petrol and how much of the diesel has to be mixed? How much of the petrol and how much of the air has to be mixed? So basically this stoichiometric mixture for a gasoline engine or a petrol engine is the ideal ratio is nothing but 14.7:1. That means for every 1 gram of fuel, that means if you take a 1 liter of fuel, there must be 14.7 liters of air is required. 14.7 mm cube or the gram or the mm cube of fuel, if you take 14.7 of air for 1 meter cube, 1 mm cube of fuel is required. That means if you want to burn 1 unit of fuel, then you need 14.7 unit of the air which makes it to burn completely for a petrol engine. So mixing up of this will always take place in a carburetor. That carburetor is its duty is to mix this petrol and air, and it can be decided by this uh, petrol and air mixture combination. This will also plays a very major role when it comes to the diesel engine. The stoichiometric, the ratio of varies from 14.5 is to 1. 14.7 is to 1 for a petrol engine and 14.5 is to 1 for a diesel engine, which gives you an ideal uh, combination of these two things. Is it clear? No. Next one is a specific fuel consumption. Specific fuel consumption is nothing but ratio of mass flow rate in kgs per hour to the brake power. So it will be kgs per kilowatt hour. This is the specific fuel consumption. Then the last one is the thermal efficiency. Even in the thermal efficiency, we have got two thermal efficiencies. One is indicated thermal efficiency, which is nothing but IP by MF into CV. CV is nothing but a calorific value of the engine fuel. Brake thermal efficiency is nothing but instead of IP, I will put BP. BP by MF into CV. Once again, CV is nothing but calorific value of the fuel.